The Oculus isn't just visually stunning, it's a technical achievement made of custom electronics, precision engineering, and hardware that pushes LED technology to its limits.
A thick human hair is about 5/1000ths of an inch. That is the tolerance pixel to pixel on this screen when it's done, in order to not see any seams or gaps. What you're seeing is a machined structure inside of a bespoke contractor-built support structure. The magic is how those two systems match up to each other and the adjustability between those two systems in order for them both to exist in their state.
We are putting up or skinning the LED material, which we think of as kind of like digital drywall. We're installing the drywall onto this frame in various key areas. Because of our tolerances of all the little pixels have to line up, our tolerances are very, very small. So what we're doing is making sure all of these modules all evenly match each other as it goes around the wall. So we're basically configuring that and massaging those to fit right in place at the right place. And then we can fill in the spaces as we need to a lot easier.
One of the significantly complex things about this project all originate from the shape of the Oculus, meaning that it's oval shaped and it's also tilting in like this, so they're calling it a truncated cone shape. Each of those different sections of the oval have different nixels, very specific nixels that are designed just for that one section of the curve to make sure that they fit properly and align properly, because they're not all interchangeable on this project.
One thing that people don't think about is the circumference or length of the top of this shape and the length at the bottom of this shape are very different. If you're trying to maintain a pixel spacing so that it can work logically with video content, you have to do certain things with your pixel spacing and the way you array the actual pixels. There's actually a variable pixel pitch as you work your way from top to bottom.
On one end, you have the playback devices, video playback servers. Those are made by a company called AV Stumpfel. They're called Pixera servers. They're super high-end video playback devices that are actually storing the video content and then playing it back in sync.
Pixera's role in the Oculus project is as the media server, so it's really just it's a computer that is acting as sort of the hub. The content team creates the gorgeous content that you'll see on the large LED screen, and that's created in Unreal Engine. So Pixera is able to open these Unreal Engine capsules directly in the media server and display that with the correct warping for the LED tiles on the screen. So this is the screen mesh, which this is a 3D mesh that Janti Home's team created to exactly match the physical structure of Nanolumen's LED tiles. It handles all of the content and handles the warping that we send to the LED processors, which then show up on the screen. In the vicinity of the Oculus structure, the LiDAR sensors that are implemented are able to kind of sense the number of people that are moving through the space, and the content can change based on the number of people. So if more people are over on the left side of the Oculus, the content will be focused over there. Those are, real-time triggers that are happening between two different software applications taking place in Pixera.
We focus on these super unique, super creative shapes, sizes, and forms. This is what we do.
This is really going to be a showpiece and hopefully a proof of concept even for some of the people that want to do more risky things with direct view LED in the future.
Don't miss episode 3 of Oculus, an immersive experience where we uncover the hidden challenges behind the build, the logistical puzzles, architectural precision, and environmental hurdles that pushed this project to its limits.